Good morning. In this first virtual computing system week of HiPEAC. So as you know, this is the autumn computing systems week. We were planning to organize this event in spring in Tampere, but due to COVID, this could not take place. And eventually we decided to postpone it until autumn, but even now we cannot organize. So we decided to make it a virtual event. So this is the very first time that we are doing this. We have compiled an interesting program, I believe, spanning 3 days with technical sessions, keynotes, and also some other meetings. Everybody is free to attend any event that they want. You can just register for it. So I hope you will enjoy it. We will also do a survey at the end to see how you liked it and learn from that, because it might be that in spring we might have to do it once more as a virtual event. But without further ado, I would like to give the floor to the keynote speaker of today, and he will be introduced by Ad. Ad, the floor is yours.
Thank you, Koen, for this opening of the Computing Systems Week. My name is Ad ten Berg. I'm Office Director at the Artemis Industry Association. And I would like to introduce the first speaker, the keynote speaker of today, Jürgen Niehaus. Jürgen is going to talk about the ECSEL Joint Undertaking program. Jürgen will explain what ECSEL stands for. It's a public-private partnership established in the Horizon 2020 framework, with its own governance, funds, and call schedules. It also has its own strategic research and innovation agenda, and the talk will give a short overview of that. Jürgen Niehaus studied computer science with focus on computer architecture at the University of Oldenburg in Germany. After working as a researcher and group leader in several research institutes and universities, he became CEO of SafeTrans Competence Network in 2006. A non-profit organization which combines research and development expertise of German industrial and academic stakeholders in the area of complex embedded and cyber-physical systems. SafeTrans is a member of Artemisia, one of the 3 industry associations in ECSEL. Without further ado, I would like to introduce Jürgen, who has several roles in Artemisia, in the governing board and several working groups, and is also chapter leads in several chapters of the SYRIA, the Strategic Research and Innovation Agenda. Jürgen, the floor is yours.
Yes, thank you, Ad, for the introduction, and also for already explaining what Artemisia is, or what ECSEL is in a nutshell. So I have been invited to present to you the ECSEL Joint Undertaking and its funding program, which is much focused on electronic components and systems, on embedded systems, on cyber-physical systems, and so which might be of interest to your community to join and participate. So what do I want to do? I want to start with a very short introduction what SafeTrans is. I'd already told you that I'm the CEO of SafeTrans, the SafeTrans Competence Cluster. Then I'm going to talk about the structure of the ECSEL Joint Undertaking, and then the main part of the talk will focus on the ECSEL SYRIA, on the Strategic Research and Innovation Agenda, which is the roadmap document that basically guides the call for project proposals in the ECSEL Joint Undertaking, but also influences other European funding programs as to the direction research should take. I will come back to the ECSEL Joint Undertaking and talk a little bit about calls and events, which give you a good opportunity to join this community and to participate in this program. I will give you a little bit information about the planned follow-up of the ECSEL Joint Undertaking, which is, well, which brings me directly to this disclaimer. that's written here. I'm not in a position to give you any official information about from the European Union, from the European Commission, from the ECSEL JU. Yeah, I'm a member of one of the member organizations of one industrial association, and so this information you get is not official communication, but it's what the current state of the discussion are from my point of view. So let me start by introducing SafeTrans. We are a German coordination and cooperation platform, basically a competence cluster. We are open to member organizations, large industry, OEMs, suppliers, tool providers, SMEs, university research organizations that have an interest in processes and methods for critical systems engineering in different application domains. We started in the mobility domain, doing lots of work in automotive, avionics, and railway systems, extending to maritime. But now we also cover health, energy, and other application domains. Always not from the application view so much, but more on the way of the, or from the view of the processes and methods and tools that you need to design these systems, that you need to verify that they are safe, that they are secure, that they have other quality attributes, and so on. And in this area, we are active in road mapping, have produced a lot of roadmaps basically since our funding in 2006, have worked a lot with and gave input to European roadmaps, basically to the, at that time, Artemis joint undertaking, and their research agenda, now to the ECSEL joint undertaking and their roadmap. We are open, we are an open organization, so basically anybody can become a member, not anybody, but any organization can become a member of our network, and we are a non-profit organization. Going to the object of this call, this is an overview of the ECSEL joint undertaking. So ECSEL is short for Electronic Components and Systems for European Leadership. And it is a program that really covers everything that in research for electronic components and systems, for embedded systems, and for cyber physical systems, starting down from wafer fabrication, chip fabrications, going up the different levels of the design hierarchy, components and modules, up to systems integration and even systems of systems. Also on the software side, from the smallest firmware models you could imagine to large embedded systems that do artificial intelligence and steer large systems of systems. It focuses on application domains like mobility, health, energy, digital industry, and agri-food and digital life. That ECSEL is a joint undertaking means that it is a public-private partnership that is established under H2020 and that has its own governance and its own funding structure. And if you look at the data that is available for what happened so far since the funding of ECSEL, so data up to 2019, we had 14 calls, we had 78 projects, we had more than 2,700 participations in these projects, and we have spent a little bit more than 4 billion euro of research, development, and innovation costs, of which roughly half of it have been funded. With these calls, you can do a little math and then see already some characteristics of this funding program. So we have only 5 to 6 projects per call which get funded. This is an average number, of course. So there are some calls which specifically target only 1 or 2 actions. For the main calls, the number is slightly lower. We have typically 7, 8, 9 projects per call, but not too many projects that are successful per call. But these projects are typically large. Yeah? You have more than 35 parties on average per project. Again, with a large variation. There are projects with 20 partners, but there are also projects with 60, 70, and even I think the current record is at slightly above 90 partners from all over Europe. So large projects, and projects which are not only large in the number of participants, but also in the number of effort that is done within these projects. So we have on average more than 50 million euro costs per project, of which, as I said, roughly 50% are funded. ECSEL is a joint undertaking. As I said, it follows a so-called tripartite model, which means that in ECSEL you have 3 partners that basically form this joint undertaking. You have the European Union that is represented through the Commission, of course. You have the member states that participate in the ECSEL program, the ECSEL participating states, so the national authorities of European states, and you have industry represented as member in this joint undertaking. And these are represented by 3 industrial associations that represent these members. And all of these associations have a lot of member organizations. Since we are ourselves a member of Artemisia, I've put them here in the front. The others have, of course, also a lot of members. Artemisia has more than 170 members, some of the which are listed here. So it's really a very large community, and it's really the who is who in embedded systems design and cyber physical systems design, and of course electronic component and systems design. This tripartite model also implies that projects that are done within the joint undertaking have tripartite funding. So they get part of their funding from the Commission, from the joint undertaking. They get part of the funding from the ECSEL participating states, and they get a part, and they fund a part of it themselves. So this is average, but it more or less already tells you how the typical funding rates for whole projects are in this program. Namely, you get half of the money funded by the Commission and the participating states, and half of the money comes from industry. At this moment in the talk, you might think that this does not sound like the easiest structure to work in. So a lot of people giving money, a lot of people, different organizations funding projects, a lot of people who want then, of course, have to have a say in what these projects should be about. Does not really sound like fun. And indeed, if you are applying for a project in ECSEL, you have to follow a lot of rules. You typically have eligibility criteria that are European-wide, so for all partners in the project, and you have to follow, of course, these eligibility criteria. You have then for each participating stage from which your project partners come, separate eligibility criteria, which might differ from the global ones, from the joint undertaking, and you have to follow all of them too. In some countries, you have to write an extra proposal for the national funding authority, so for the participating states. And if you want to get your money back, so the organization of the refund is also a part goes to the joint undertaking to get a part of the money back. Some other part goes to the member states to get that money back. And it's really, from an organizational overview, it's more than you typically expect in an H2020 project. So this raises the question, is it worth it, going here? And the answer here, or my answer here, is a clear yes. And why is it a yes? It's because of basically three reasons. One is what is written here on the right side of the slide is really, you have here the community. You have here really the who is who in ECS design, in embedded systems design, and cyber physical systems design. You have a lot of events where you actually meet these people, where you can discuss with them, where you know where industry is heading, and what which of the research topics that you might pursue are actually of industrial relevance. You have a lot of opportunities to see that although all these industry people do different things, they have a lot of problems in common where research is needed to do this work. So the community building and the discussions with all these partners are really a big plus side of programs like these. The other reason why I say yes, this is worth it, was already on the last slide. Projects that come in the ECSEL joint undertaking are really large, and they really have a high impact, and you really can get things done in these projects. And so they differ not from all, but at least from some of those projects that you typically find in H2020, by really having a high impact and doing working on topics that are really of a high industrial relevance. But the main reason why I say yes, working here in this joint undertaking is really worthwhile, is that we have this research roadmap that we follow. So ECSEL is not well just a collection of topics, of challenges that you might or might not do in a project, but we really have this large document, which is which is called the Strategic Research Agenda. In some years we call it the Strategic Research and Innovation Agenda, and which really collects all the topics that industry agrees on and industry and researchers agree on that are worthwhile doing in these program, and that really represent challenges that have to be solved to increase European competitiveness and so on. So this research agenda is written by the members of the three industry associations. There's a large or rather complicated process of how this gets approved, but it's written by the industry associations and by its members. So alone the fact that this document is written and published requires a huge harmonization effort, many discussions with all these members, and you can learn a lot of where industry is headed and what are the real challenges in this domain by participating in writing this document. This picture again shows it. So the member organizations write this research agenda, it is approved, and then it is the basis for the calls for the ECSEL joint undertaking. But it also influences other European program, because this is really meant to represent the whole of electronic components and systems research that is necessary in Europe. So we have written the first version of this research agenda in, what was it, I think 2013 or 2014, when ECSEL started. And we decided at that time to structure the research topics of this agenda in a two-dimensional structure, having the essential capabilities, which are basically the technologies that you need to produce the applications in one dimension, and the challenges stemming from the application domains in a second domain. I'm only showing you this picture because you might still see it. This is the structure of the SYRIA up to this year, guiding also the still running call of this year. There was a decision to write a new version of the SYRIA, major update, but basically it's a new, completely new version, which follows a slightly different structure, basically a three-dimensional structure, or 2.5-dimensional structure, where we have on the one dimension in the horizontals the foundational technology layers, and they are ordered like a stack coming down from wafer and chip process technologies, going over components, modules, and modules, embedded software, and beyond, up to systems of systems. So representing in a way the different levels of the design hierarchy that you have. We have a second dimension which covers the cross-sectional technologies. So all the technologies that are needed and which cover more than just a single layer of the design stack, of the technology stack. Basically, they cover all of them. And then we have in this arc above the picture the now 6 application domains that we are covering. This document, the SYRIA, also has a long-term chapter with topics that are already visible at the horizon, but which we are not pursuing right now. It has, of course, an introduction, it has a glossary and so on, but the main content of the SYRIA are one chapter each for the technology layers, the cross-sectional technologies, and the application areas. What I want to do is now is to give you a short overview about the content of each of these chapters. Each of these chapters identifies major research challenges, which are then further divided into what they call key focus areas and then the concrete research topics. So there's really a lot of stuff hidden behind each of these challenges. But I think the list of challenges will give you a good impression of what the actual content of each chapter and their and also the content of the whole SYRIA is. So starting with the technology layers and starting with the closest one to the chip level, process technology, equipment, materials, and manufacturing, we have as challenges advanced computing, memory modules, and compute. So basically, it's all the technologies that you need to produce chips, new devices, new circuits to support advanced functionality, advanced heterogeneous integration and packaging on the chip and wafer level, and all topics that you need for semiconductor equipment and manufacturing technology. So this is the layer nearest to the chip. Going one level up to the components, modules, and systems integration topic, we have here the challenges of the most important one is those of physical and functional integration, which covers all the topics that you need to integrate these chips and these components into higher level structures like modules and complete systems. You also look at materials that you need to do this integration and that you want to integrate your chips with. You have a look at technologies, manufacturing and integration processes. And of course, you also have to look at your at the Green Deal, basically, so at decarbonization and recyclability.
if you now have these modules, one level further up is the embedded software chapter, where everything from, as I said, from firmware for these components and modules up to large systems of software for large systems of systems is covered, and we have challenges that focus on how to engineer these software, how to do continuous integration, namely updates, upgrades of software in the field, how to cover the whole life cycle management of embedded software, and also support for big data, so for data analytics and support for artificial intelligence, and also what can software do to support the Green Deal of the European Commission. Next level is the systems of system levels, where we talk a lot about architectures of systems, where we have a large challenge of interoperability within systems of systems. Component systems are typically manufactured by different OEMs. So how do they work together? How can they communicate and so on? Composability of embedded and cyber physical systems into SOS is a related challenge here. Then, of course, again, the questions of how to engineer such systems and what to do about openness of these platforms, which is also needed in a industry that is structured like the European one, where many different players compose a system of system platform and contribute to a system of system platform, perhaps in contrast to what's done in other parts of the world, where you have one player who basically supports its own very large platform. So openness is a very large challenge here. After the technology layers, we have the cross-sectional technologies, where we have the topic of artificial intelligence, edge computing, and advanced control. This is basically all these new technologies that need to be supported via all the levels of this design hierarchy. And the challenges here are how to do this in an energy efficient way, how to cope with the increasing complexity of these systems, how to support the increasing lifespan of these systems, and how to ensure that these technologies can really be done in a sustainable way in Europe, so that we are less dependent upon imports that we need to do here. Second cross-cutting topic is about connectivity. Again, covers all the different layers. Again, reflecting also the fact that we have here many companies that produce systems that need to connect to each other and that need to communicate with each other. So this chapter also covers challenges from the purely technology ones, like how to incorporate 5G and perhaps even 6G technologies at some time, how to develop new communication media or means, and then again the topic of interoperability, translation or interoperability, here represented by doing automatic translation for all the data that is exchanged, even if they are between different systems from different OEMs. Architectures and reference implementations, of course, is also a large topic here. Next chapter is about architecture and design, methods and tools. This is the chapter that I'm co-leading with 3 colleagues from Siemens, from the EDA Centrum, and from AVL.
And this is not about the technologies that we want to develop as such, but it is about all the tools and all the methods and processes that we need for building these systems, and not only building them, but building them with the required qualities like safe systems, secure systems, reliable systems, and so on. And our main challenges here are to extend the development process that today only typically only cover the design phase of design and test phase of these systems, to really extend them to cover the whole life cycle. This is about tools that we need to support new functionalities in safe, secure, and trustable systems. And this is about how to make the complexity of these systems and also the diversity, in the sense that you have many different technologies, that you have many different technology domains that you need to consider, that you have analog and continuous domains which you need to integrate into one system, and how to cope with and how to give tool support and process support to manage all this complexity and all this diversity that these systems exhibit. Last chapter that I want to talk about here is the quality, reliability, safety, and cybersecurity chapter, which is about all these additional requirements that you typically have for such systems. They need to be safe, they need to be secure, they need to be reliable. And how do you ensure this, and which steps or which research is needed to ensure that this is also true for future embedded systems, for future cyber-physical systems. The application chapters that we cover in this SYRIA are the 6 that I already mentioned. I will not go to the challenges posed there. You can probably guess a lot of them. Yeah, just think about words like autonomous, smart, affordable, high quality, safe, secure, and so on, and put mobility, energy systems, digital industry, and so on behind those words, and then you already have a lot of these challenges. This is not to say that they are boring. It's really it is good to read this part of the SYRIA in order to get a feeling of why it is necessary to have affordable mobility, why it is necessary to have smart energy system. And so these represent a kind of challenges that really do an excellent job in showing us in which direction these our research should be headed. Yeah, but from my opinion, the real music of ECSEL, so to say, plays in the first 2 categories, and there are the research topics that really are challenges, and these chapters provide a way in which direction we should go. So coming back to the actual JU, as I said, the SYRIA will cover the calls in the next will be the basis of the calls of next year in the ECSEL JU. An excellent way to participate in the community is joining the different events that the 3 industry associations or the ECSEL JU itself is producing. We have in November the FX conference, which was planned to be held in Berlin, but which is also now a virtual conference. This is the main conference for the ECSEL joint undertaking and for the funding program. It also includes a pre-brokerage event, which is a way in which you can present your own research topics and try to find cooperation partners using, of course, direct interaction with the other people that are there, but also using the ECS collaboration tool that is provided there, which is an online instrument where you can present your project idea and find partners. There is a dedicated brokerage event planned in midst of January. There are different calls that more or less depend on this SYRIA, and so it's all of these are typically joined by special networking events, special preparation events that you are really invited to join. You may ask, why do you write a new SYRIA, seeing that Horizon 2020 is ending and this ECSEL is ending? And this is the part of the talk where I have the least information, but it is planned to have a successor joint undertaking in Horizon Europe. The working name here is Key Digital Technologies. And the scope is basically the same as that of the ECSEL JU, but some of the elements like photonics, software, advanced computing, flexible electronic technologies, and more will probably be more explicit in the scope. But basically, you will be able to recognize it from what is done now in the ECSEL JU and what is now described in the new SYRIA. Budget of this joint undertaking is very much unclear today. There was a proposal of substantially increasing it, but then again, we have the Corona recovery programs from the joint undertaking, and we have a corresponding budget shortening in Horizon Europe. So it's not quite clear what will happen there, but I think chances are very high that there will be this new joint undertaking, because basically Europe cannot miss this opportunity. You cannot say we want to do digitalization, we want to do become a world leader and support our industry, and then not have a joint undertaking or a special funding program for all these technologies that are needed there. Okay, in summary, I already took too much of the time. So ECSEL joint undertaking is a public-private partnership with a tripartite model. It has annual calls. It follows a strategic research agenda. We have projects that are typically of high volume and also of high impact. And we have a very strong ecosystem, and you are very much invited to join this. Therefore, I thank you for your for listening to me, and I'm open to questions.
Okay, thank you, Jürgen, for this very informative overview of the ECSEL joint undertaking and its program. As you know, I see no open questions on the Q&A screen. So I have one question that I would like to ask. As you know, most of the HiPEAC members are active in high-performance computing. Could you elaborate shortly on the role of high-performance computing in ECSEL and the ECSEL program and its projects?
Yeah, I would like to. So in the ECSEL SYRIA, we also always talk about embedded high-performance computing. Yeah, so high-performance computing, of course, has a lot of stuff in the IT world. Yeah, but you see that we need, for all these new functionalities, we need a lot of processing power. Yeah, and it will, in most systems and also in most autonomous systems, it will not be sufficient to have this somewhere in the cloud, all this computing power, all this memory power, all this data processing power, but it will be necessary to have them inside the system, inside the autonomous car, inside the autonomous system that you are building, or at least in the edge, so very close to this embedded system. So all this stuff and all these technologies that you need for high performance computing, if you can put it on a level that we call embedded high performance computing. It's very much important to have this in the future systems.
Okay, thank you very much, Jürgen, for this answer. Are there any other questions? I see nothing on the Q&A list. And I forgot to say that people can ask questions through the Q&A.
I have a question.
Okay. Yes.
Jürgen, it was quite a very interesting talk. So I was wondering, how does the SYRIA deal with the European Green Deal? Did it change anything from previous documents that you produced?
We have put quite a strong focus on the Green Deal. You see it. So the overview that I have given you now is on the technical level, yeah, on the challenges which within each of these chapters. So in each of these technology layers also, and even there you saw some challenges that explicitly mention decarbonization, that explicitly mention the Green Deal, that explicitly mention recyclability, and even those where it is not directly visible. Yeah, this covering the whole life cycle stuff for processes and methods. Yeah, explicitly focuses also on the end of life of such a system, and therefore for recycling or how to do this. And so this comes up on quite a lot of topics in this SRA. And then we have also, which I did not talk about here, we will have in the introduction and also in the what is called the Part A, which is a strategic document saying how important this joint undertaking is. We will also have an explicit reference to all the European strategies, including the Green Deal, that we are following here.
Okay, thank you. I see now two short questions. I'm not sure whether we have time for it. The first is that the question, will there be an ECSEL call next year, or is the new KT? Yeah, I think I can answer that one, because it will be indeed a new KDT. The last ECSEL call has been this year, 2020, and next year it will be the KDT call, and that depends very much on when KDT will become active. So it will be most likely later in the year. And there are more questions, but as the time has already passed, we are 10:12. I propose to now stop this Zoom session and step over to the next Zoom session in the Computing Systems Week. Thank you for your attention and hope to see you in the next Zoom webinars.